All right, so here we have the last example that we're going to go through. This one is very much lab-like. So if you're having some difficulties with your labs that are going to be assigned in this particular part of the chapter, take a look and remember number 5. In this one, you have your balanced equation. It is all 1-to-1 ratios. Again, you have 1.84 grams of your limiting reagent, and I know it's limiting this time because I am told that copper 2 sulfate is the excess. Please read these carefully. Not all problems have you determine and work through all that extra stoichiometry of figuring out which is limiting. Expect 1, perhaps 2 on a test, but most of them will try and shortcut that for you because we don't need you going through all of those things here in Chemistry 20. This becomes more realistic as you go further in chemistry, and so when you're fully committed to dealing with the chem problems that are at hand, you'll be more willing to deal with all of the repetitive stoich that can come with it at times. So you have 1.84 grams, and we're trying to determine the percent yield if 1.5 grams of precipitate is actually collected. Note by the terminology that this is the experimental amount. What we're missing is the prediction for how much we were supposed to get before we could predict a percentage yield. So we need to figure out another mass for strontium sulfate. So 1.84 grams of strontium nitrate, that is not comparable because of the different masses. So what we need to do is turn this into a molar mass, and with that, into a mass based moles based upon molar mass. I'm done with these videos for today. And here we go. So the molar mass of strontium nitrate is 211.64 grams. Grams now cancel out of the problem, and we are down to a mole quantity of strontium nitrate. Fantastic. Now we can go to the stoichiometry, and the stoichiometry is fairly simple here. We want to get rid of our strontium nitrate. We want to get to strontium sulfate, which is on the other side, and you can see the 1-to-1 mole ratio here. And so that cancels out, and now you have moles of your product. The problem is, to compare to 1.5 grams, we need to get this into a mass, so we need one more conversion. And so moles now have to go on the bottom, grams up top. 1 mole of strontium sulfate now should weigh 183.69 grams on the scale. Moles cancel, and you have grams of strontium sulfate. So we run that through our calculator really quickly, and 1.84 divided by 211.64 times 1 divided by 1, I don't need that in the calculator, and then times 183.69 gives me 1.59700 grams of strontium sulfate that I was supposed to get. So you can see that we are fairly close here. 1.5 doesn't sound significantly different than 1.597. Okay, this is an intermediate step. Since it did not ask us to figure out the actual mass, we're going straight to percentage yield. And so we'll just plunk that one in here. Percentage yield is equal to the actual over the predicted or experimental, over the predicted or theoretical. And so that would be, your actual amount was 1.50 grams. I'm working sideways here because I'm running myself out of space. Your predicted was 1.597 grams. Multiply that by 100 to turn it into percentage. And we see that we're fairly accurate here. 1.50 divided by 1.59 works out to 93.9% efficient when you round it to your 3 sig dig limit. Now there is one more question here that we can work through. We can calculate the amount of excess reagent required. For that one then, we're trying to figure out how much of this should we actually use. Very similar back to question 2, I think it was. We were trying to figure out how much we should use there. So we know 1.84 grams is still the limiting reagent of strontium nitrate, and now we want to get through to the copper 2 sulfate. So it's another stoichiometric prediction. We have 1.84 grams of our strontium nitrate. But in this case, we have to use the molar mass of strontium nitrate to get to our moles again. If you stopped and figured out that number, great. Most of us wouldn't, so we redo the calculation. Grams now go. I can now take a look at the mole ratio, but in this one it's pretty easy. Strontium nitrate and copper to sulfate are in a 1-to-1 ratio, but that does eliminate the strontium nitrate for me. And now I have moles of copper 2 sulfate. I'm going to turn that into a mass so I can figure out how much I need to weigh out on a scale. And from that, moles you can see go down on the bottom, grams here. And 1 mole of copper 2 sulfate is 159.62 grams. Moles now go. And so we can figure out how much we should use as a minimum here by doing this. So 1.84 divided by 211.64 like we did earlier, times 1 divided by 1, doesn't have to happen in the calculator, and then just multiply by 159.62. And it says you need at a minimum 1.3877 grams. Now remember, we're using a 10% excess rule, so we need a little bit more than this to ensure that the whole reaction happens quickly. So I would multiply this number by 1.10 whenever I'm trying to figure out what I should use for my XX reagent. And the best answer I would have is 1.53 grams when I round accordingly. There you go, guys. That is a bunch of examples on gravimetric stoichiometry, trying to rush them through here in a bunch of little videos. What I want you guys to do is read through 290 to 293. You can take your time with those examples as well that are in the textbook. Those blue little example sections are actually pretty good. And complete questions 5 to 10 on page 293. Take a look at the lab assignments 7A and 7B. 7A is coming in for a Dropbox assignment. 7B, I'm going to leave that one alone, but you can certainly try it, and you can take a look at the answer key that you will find on D2L. But 7B, there is a bit of an error with how it was printed in your book. There is no prediction to do. You just have to write out your balanced chemical equation. Unfortunately, no real labs with at-home learning. We can't do this one as awesome as it would be to do with you guys. You can eliminate 7.2. So 7A and 7B, you should probably take a look at. 7A is definitely coming in for a Dropbox assignment. All right, a couple more lessons to go. We're going to take a look at gas law stoichiometry and solution stoichiometry next.